Okay, so learning outcome 31. And it says, explain the concept of work done. And the phrase that's usually used there is, work is done when energy is transferred. Or to phrase it slightly different in a way, that's a kind of standard phrase that you'll see often in textbooks. But I think this way maybe makes a wee bit more sense. The value of the work done is the amount of energy transferred or changed in any situation. So a couple of examples, e.g. a car accelerates from rest to a kinetic energy, and we will come back and define kinetic energy later, of 150,000 joules. And because it started at rest, it had zero kinetic energy. So the work done here is simply how much the energy changed by. So it's simply 150,000 joules. It then breaks so it slows down a bit, and its kinetic energy goes from 150,000 down to 100,000. In that case, the work done is the change in energy. So it went from 150,000 down to 100,000. So the work done by the breaks there would be 50,000 joules. Is a formula for work done. And this isn't one that we prove at all. It's basically the maths behind this formula. Although it's a simple formula, the maths to prove it is way too complicated at this stage for you. So you kind of have to take our word for it a wee bit. And that's work done, so that's E with a subscript W, is force times distance. Okay, so if work done is a change in energy, and we've got this idea that you're familiar with anyway, that forces cause changes in speed. In general terms, forces cause changes in energy. And we can link them together. So EW stands for work done, measured in joules. F is and I'll put unbalanced, because if there is more than one force, you'd have to work out the unbalanced force. And D is the distance, measured in meters. And we'll just copy the example that we looked at yesterday. The car engine applies a force of 3,000 newtons over a distance of 200 meters. Calculate the work done by the engine. The standard problem solving techniques, what do we know? We've got the force of 3,000 newtons. Got the distance, it's 200 meters, and we've been asked EW. EW is FD, EW is what we're working out, but we can substitute for F and for D. And we see that for things like cars, hundreds of thousands of joules are not uncommon. Okay, I'm going to change the order very slightly. I'm going to do 34 before 33. I think it makes more sense that way. 34 is define gravitational potential energy, and then 33 is the formula, and I think it makes more sense to give a definition first. So, gravitational potential energy, it's a bit of a mouthful, is the stored energy an object has by being high up. Right, so at the top of a hill, up on a shelf, just if you've lifted it, anything, any situation like that. Now when we're, for instance, working in a lab, like this for instance, usually, when you were doing that experiment there and lifting the mass up from the bench, then you placed the bottom of your roller on the bench and you measured how high up it went from that bench. You don't measure back down to ground level every single time. So you can look at just the change in height that you're interested in. Basically, you can define your zero to be whatever's convenient. 33. And we looked at the derivation of this formula, so starting with the work done and replacing the force by the weight, mg, and the distance by the vertical distance, h, the height. Then we get this formula. So EP is gravitational potential energy, and that's measured in joules. M is the mass, remember, in kilograms. G is the gravitational field strength. Gosh, there's a lot of long definitions in here, which remember is newtons per kilogram. And H is the height, which needs to be in meters. So if you've got a measurement in centimeters, make sure you convert. And a simple example. Let's make it a wee estimate question. Estimate the gravitational, that should say potential actually. Potential energy gained by walking to physics on the third floor. So we're not getting very much in this question. We're obviously being asked EP, but to get an estimate for EP, we're going to need values for M, G, and H. So what would be a reasonable estimate for a mass of a person, do you think? How many kilograms? Probably most of you might know your mass in stones and pounds and stuff like that, but in kilograms, anybody any ideas? Yeah, 50 would be right for about a pupil. An adult, you're looking at 80 maybe. Okay, but for a pupil, we'll take it as 50 kilograms. G, we know. Okay, we are assuming it's on Earth. Right, the question doesn't mention anything else. What about H? Any ideas how high up we are on the third floor? If you broke it down to one floor at a time, could you estimate the height? How big do you think a flight of stairs is? 15 metres for one flight of stairs. For this floor, yeah. So 5 metres per floor, 3 floors up, 15 metres. That would be reasonable, okay? If you think about how tall you are, right, do you all agree, I mean, probably about 1.5 to 2 metres, somewhere in that range. Think about comparing that to a flight of stairs. It's going to be, maybe about three times your height. So a flight of stairs, 3, 4, 5 metres would be a reasonable estimate. So for 3 floors, we'll take our estimate to be 15 metres. And now we can work out EP equals mgh. And then just plug into your calculator. Okay, so we'll get a final answer there. 7,350 joules would be a reasonable estimate.